Welcome back to Math Easy everyone. In today's lesson, we will discuss the congruency of triangles by SSS and SAS postulates. But before we move on to discussing the congruency of triangles, let's briefly go over some definition, some properties that we will use in congruency throughout this lesson and following lessons. The three properties of congruency in geometry are reflexive, symmetric, and transitive. What are those properties? Reflexive property: any geometric figure is congruent to itself. For example, a segment AB is always congruent to itself. So if I have been given a rectangle and if I divide this rectangle into two parts by a diagonal and name this A, B, C, D, then AC, since it is being shared between the two triangles, will be congruent to itself. Symmetric property: if two things are congruent, then no matter how you use them, they will still be congruent or the same. For example, if angle A is congruent to angle B, then angle B is also congruent to angle A. If angle B is congruent to angle A, then you can use the symmetric property and say that angle A is congruent to angle B. And transitive property: if two figures are congruent to a third figure, then they are congruent to each other. So if angle B is congruent to angle C and angle C is congruent to angle A, then angle B will be congruent to angle A as well. So that would be your transitive property. What is congruence? We have been using this word a lot. Congruence is an adjective that describes two shapes that are the same in shape and size. For example, two congruent triangles would match up exactly if you lay them on top of each other. The word comes from the Latin verb congruere, which means to come together or correspond with. So I just like to remember this with a simple example. If you take an A4 size paper, two A4 size papers, and if you put them on top of each other, they completely overlap. So if you put them on top of, this is paper 1, and I can go ahead and draw a similar paper of the same size, they will 100% overlap each other. So if two shapes have exactly the same angles and the same side lengths, then they will overlap each other and will be congruent. So we can talk about any shape, but in this lesson we are discussing the congruency of triangles. All right, let's move on to the theorems. The first theorem that we will discuss today is SSS congruence theorem. If three sides of one triangle are congruent to three sides of the second triangle, then the two triangles are congruent. If three sides of one triangle, so I can also draw this. It has already been drawn for you here. If I have triangle A, B, and C, and the corresponding sides are congruent, so I can see that AB, line segment AB is congruent to line segment DE. Line segment BC is congruent to line segment EF, and AC is congruent to DF. Then from the side congruence theorem, triangle ABC is congruent to triangle EDF. All right, let's take an example. And the next theorem that we will discuss will be side angle side congruence theorem. In side angle side congruence theorem, as I also discussed in my previous video, remember you are talking about two sides that are congruent to the corresponding two other sides of another triangle, but we are only talking about an angle that's been included between the sides. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. All right, let's learn this by taking an example. So I have one example here. Proving triangles are congruent. What we have been given. So please remember that in geometry, it is very important to pay attention to what has been given to you. What is given? Line segment AB is congruent to line segment CD. AC is congruent to BD, and I need to prove that these two triangles are congruent. Okay, so we have the work laid out for us, but as an instructor and a teacher here, I can give you one simple suggestion that when you are working on the geometry and you need to prove the congruencies, please write down all the congruencies somewhere in the corner that you remember. So I remember that I'm working with SAS, SSS, but I also know the other congruencies. So what I will do is I will lay this all out on the corner sheet of my paper, and then I will see what all has been given to me, and then from there I will figure out which congruency I can work with. So I have been given that two sides are congruent in these two triangles. So first write down the statements. In the statements, please always start with what is given to you. You have been given that AB line segment AB is congruent to line segment, line segment AB is congruent to line segment CD, and it's good to visualize in geometry. And then the other thing that's given to you is line segment AC is congruent to line segment BD, and what is the reason? This is given in the question. So remember, because we are discussing SSS, it is kind of a hint to us that, oh, okay, we are discussing SSS, so we just need another side. But what if you are just working on a question in the quiz and there are all the properties that can be a possible answer? There is only one property though. There are only two properties though where two sides work. So the properties are SSS and SAS. And which one do you need to choose? Let's say if the answer is SAS, then we have to look at the angle that is included between the two sides. If I can prove that this angle and that angle is congruent, then I can go ahead with SAS. But right now, I have an easier way to do this. Maybe that will also work, but I have an easier way. And what is that? We have a line common between the two triangles. You can see that CB is a common line. So from the reflexive property of congruency, which we just discussed, line segment CB is congruent to line segment CB. So now I have three sides that I proved congruent to each other. In the corresponding triangles, I can say that triangle ABC is congruent to triangle DCB. Let's take a practice example. So on the left side, I will be writing my statements, and on the right side, I will be writing my reasons. So my statement number 1 is MQ, line segment MQ is congruent to line segment MR, and my reason is that this information has been given to me. Also, line segment QP is congruent to line segment RP. Again, this information has been given to me. So then I can work with two sides are given to me as congruent side. So I have to find the third side or an including angle. We can see that again we have a common line. So a common line is always, you can use the reflexive property and say that line segment MP is congruent to line segment MP again, and the reason could be reflexive property of congruency. So now we have three sides that we proved are congruent to each other. So then from SSS postulate or theorem, you can say that triangle ABC is congruent to triangle DCB. Okay, let's move on to the second congruency that we will discuss today, side angle side. So in case you cannot prove that three sides are congruent to other three sides, if you do not have that information, but you do know that two sides have been given, then the another theorem that you can think of it is SAS, but you have to prove that the angle which is included between the congruent side is also congruent. So let's look at this example. I can see that what is given to us, the figure with congruent segments are shown with the equal number of tick marks. So I can see that AB is congruent to AC, not BC. AB, line segment AB, is congruent to line segment BC, and this information has been given to us. Line segment EB is congruent to line segment BD. This information has also been given to us. So the third thing is I can either find a congruent side or I can find an angle which is being included. So let's look at this part here. So angle included between the congruent sides. So remember, it could not be this angle and it could not be this angle. That's a big no-no. Why? Because those are the sides which are congruent. So you need to find an angle that is being included between those two sides. Alright, so let's see that angle is congruent to the other angle. And why? Because they are vertical angles. So I can say angle 1 is congruent to angle 2. Vertical angle theorem. I have two sides which are congruent and the angle included between them. So I can say that triangle ABE is congruent to triangle CBD by SAS postulates. Let's take a look at an example. Line segment AC bisects angle BAF. So let's see where our angle BAF is. BAF is this angle. So if it is bisecting, what does the word bisecting means? It is dividing this angle into exact two halves. So I can write here angle 1 and angle 2. So let's start by our statements and the reasons. And we can see that the equal sides have been tick marked. Angle side line segment AB is congruent to line segment AF. And why? We can see the tick marks. So we can say that it is given. Now look at the side AC. Side AC is a common side. So by reflexive property, line segment AC is congruent to line segment AC. Reflexive property. And I have two sides which I just proved are congruent. So I need to prove that the angle included between them are also congruent. So I can go ahead and say angle 1 is congruent to angle 2. Why? Angle bisector theorem. Angle bisector property. angle 1 equals to angle 2. So we just proved that the two sides and the angle between them are congruent. So we can say that triangle ABC is congruent to triangle AFC by SAS postulate. Okay. All right. Let's quickly take a look at some examples. Name the postulate you would use to prove the triangles congruent. So what I can see that I have two sides congruent and the angle between them are vertical angles, and vertical angles are congruent too. So this congruency would be proven by using SAS. Let's look at question number 6. I have two sides given congruent to each other. This side, and then we have those two sides that are congruent to each other, and then we have those two sides that are congruent to each other. Along with that, we have a line which is common between the two triangles. So applying the reflexive property for this line, we have now three sides. So this will be proven congruent by using SSS postulate. What other information, if any, do you need to prove the two triangles are congruent by SAS? Explain. Let's take a look at example number 7. What do we have? So we have been given that those two sides are congruent, and then we have been given those two angles are congruent. So to prove congruency by using SAS, we need to prove that another side is also congruent. But which side? Can it be this side? Take a pause, think about it. It cannot be this side, because if we want to prove congruency by SAS, then the angle should be the angle between the congruent sides. So it could only be those two sides. So what do we need to prove? We need to prove, so how can I answer this? Need to prove that LG is congruent to MN if we want to prove the congruency using SAS. All right, practice 8. We have been given RT is congruent to VW and TS is congruent to UV. So to use SAS, I have two sides which have been given congruent. So I need to prove the angles between the two sides as congruent. So what do we need? We need to prove angle T is congruent to angle V if we want to prove the congruency using SAS postulate. All right, everyone, this is it for today. Don't forget to like this video and subscribe to Math Easy. I'll see you later. Bye for now.